Today we're going to be talking about section 8.5, which is on adding and subtracting rational expressions. Our goal in this section is to just do that, add and subtract rational expressions. So remember, when we add or subtract, we always have to do it with like denominators. All right. So our goal is always to get a common denominator. In these first few examples, they already have a common denominator. So we're just simply going to add the numerators and write it over that common denominator. So if we look at example 1, it's going to be 12 minus 2, which is 10, over 5x. And then we have to check, does that reduce? And in this case, it does. We can take a 5 out of both of those. And so our answer is going to be 2 over x. Same thing is true for b. We already have a common denominator, so you just add your numerators. Well, we have 3x plus 1. Well, we can't do anything with those two because they're not like terms. So it's going to be 3x plus 1 over 2x plus 5. And that also does not reduce anymore. So very simple. If we have common denominator, we simply add the numerators up and put it over that common denominator. So here are 4 guided practice questions. I can do a couple of them. Go ahead and pause the video and you can hit play when you are ready to resume. And here are the answers to the guided practice questions in 1 through 4. Notice we always just add or subtract the numerators, write it over the common denominator, and then simplify it if we can. The next thing we're going to look at is adding or subtracting with unlike denominators. So just like when we add or subtract fractions, if we don't have a common denominator, we have to find one first. In the process of doing that, it says you can always find a common denominator of 2 rational expressions by multiplying their denominators as shown. However, it is if you use the least common denominator, the LCD, which is the least common multiple of the denominators, you may have less simplifying to do at the end. So our goal is to find the smallest common denominator so we don't have to spend so much time reducing when we are done. So example 2 is going to take us through that just a little bit. So the first thing we're going to want to do, we have 2 polynomials here. And so what we're going to want to do is we're going to want to factor them. So if we look at the first one, I can take a 5 out of there. So we're going to get 5x squared minus 9 if we factor that. And so this is really 5 times x minus 3 and x plus 3. If we factor the second one, we can take a 4 out of that. So we're going to have 4x squared plus 6x plus 9. And this is going to factor to x plus 3 and x plus 3. And so now I have these both factored completely. And we want to find what is the LCM, the least common multiple. Well, I need every part of both of those. So I need the 5 and I need the 4. So that's going to give me 20. I need an x minus 3, which I have in the first one. I don't have it in the second one. So I need it there. I have 2x plus 3's in the second one and 1x plus 3 in the first one. So I'm going to need both x plus 3's, but I don't need 3 of them because I already have one of them in there. So this would be my least common multiple. So what we're going to do in example 3 is we're going to use some of that to figure out what we need to do to get like denominators. We got to get a common denominator so we can add these two. So the first thing you're always going to want to do is you're going to want to factor them if they're not factored. So if we look at the second fraction is not factored. So if we factor it, I'm going to take out a 5x, and that's going to give us x minus 2. And the first one obviously is just 10x squared. So we want to find a common denominator. And the common denominator here that we're going to look for is 10x squared. We have that in the first one. Now notice we already have the 5x from the second one. That's part of the 10x squared. And I need an x minus 2. I need that in both parts. So 10x squared times x minus 2. All right, so if we look at the first one, here I have the 10x squared. I need the x minus 2. So I'm going to have to multiply this top and the bottom by x minus 2 to get to that denominator. So this is really going to be 3x minus 6. In the second one, I'm going to need to multiply this by a 2x, because that'll get me to 10x squared times x minus 2. So that's going to give us a 4x squared. So now, since I have a common denominator, I simply add them. So I'm going to get 4x squared plus 3x minus 6 over 10x squared times x minus 2. And this problem will not factor any further. So here is your simplified answer. All right, example 4. We're going to, again, subtract with unlike denominators. So once again, we have to always try to factor these. So I'm going to take out a 3. We're going to x minus 5. In the second one, we're going to factor this. It's going to be x minus 5 and x plus 1. So we have to get a common denominator, and it's going to be 3 times x minus 5 times x plus 1. All right, so if we look at the first fraction, we have the 3, we have the x minus 5, we need the x plus 1, so we're going to have to multiply the top and the bottom by the x plus 1. So that's going to give us x squared plus x. In the second one, we have the x minus 5, we have the x plus 1, we need the 3. So we're going to have to multiply this one, top and the bottom, by 3. So if we do that, that's going to give us 6x plus 6. And again, we have a subtraction, so we're going to subtract these straight across. So we're going to have x squared minus 5x minus 6 over that denominator. And then we have to check to see if it factors, or if we can simplify this any further. And it looks like this one might. So let's try to factor it. Do it over here so we make some more room. This will be x and x minus 6 plus 1. This is 3, x minus 5 and x plus 1. And if we notice here, the x plus 1s will cancel out. And we're going to be left with x minus 6 over 3 times x minus 5. And there's the answer for example 4. All right, and here are a few guided practice questions. The first 2, 5, and 6 are on finding the least common multiple. 7 through 10 are on adding or subtracting fractions with non-common denominators. So go ahead and pause the video. You can hit play when you're ready to resume. And here are the answers to those guided practice questions. Now, if you notice again, we always have to get a common denominator before we add or subtract fractions. So in questions 7 and 8, 9 and 10, we had to get a common denominator before we add those. And for questions 5 and 6, all we're doing there is finding the least common multiple. The next thing we're going to look at in this section is on simplifying complex fraction. Now, a complex fraction is a fraction that contains a fraction in it, both its numerator or its denominator, or it could be even just one of them. But a complex fraction can be simplified using one of two methods. Method 1 says we're going to simplify the numerator and the denominator by writing each as a single fraction. So we're going to take the numerator, we're going to simplify it. We're going to take the denominator, we're going to simplify it, and then we're going to divide the numerator and the denominator. So let's jump down to example 5 and look at how that works. Well, we have two fractions here. We have 2d in the numerator, and then we have d over r1 plus d over r2 in the denominator. Well, we could really write this as 2d over 1. And so method 1 says we're going to simplify each part of this fraction by itself. So we're going to take this part of the fraction, and we're going to get a common denominator there. So if we do that, my common denominator is going to be r1, r2. And if we do that, then we know that this is going to be d times r sub 2, and this one's going to be d times r sub 1, because that's what we needed. Now, if we add our like terms up, we're going to get 2d over dr sub 2 plus dr sub 1 over r sub 1, r sub 2. And we know that division is the same as multiplying by the reciprocal. So if we do that, we're going to have 2d, and this is really over 1, times r sub 1, r sub 2 over dr sub 2 plus dr sub 1. Running out of space there. Let's move that over here. So 2d over 1 times r sub 1, r sub 2 over dr sub 2 plus dr sub 1. Okay. So we're just going to move that over here. And then if we simplify this, I can take a d out of both of those. Using the distributive property. So here we can see that these d's are going to cancel out, and our answer is going to end up being 2 r sub 1, r sub 2 over r sub 2 plus r sub 1. And that would be our answer. Now we'll do a guided practice question here that may make more sense than this one did because of all of the variables, but that's how you do method 1. Method 1 is we're going to simplify the numerator into one fraction, we're going to simplify the denominator into one fraction, and then we're going to divide them when we're all done. Method 2 states this. I'm going to get a common denominator with every fraction in this thing. All right, so we're going to multiply the numerator and the denominator by the least common denominator of every fraction in the numerator and the denominator, and then simplify it. So if we look at example 6, here are my denominators. And so we are going to get one common denominator through the whole thing. Well, in this case, it's going to be x times x minus 5. So here's how I'm going to do this. I'm going to say x times x minus 5. And I'm going to have an x times an x minus 5. So there are my two in the numerator. And then I'm going to do the same ones in the denominator. I got to get the same common denominator. So now we have to look at what did we need. Well, in this part, I just need an x because I already have the x minus 5, so that's going to give me 6x. In this one, I needed the x minus 5. So 1 times x minus 5 is x minus 5. Down here, we needed the x minus 5, so that's going to give us 3x minus 15. And in this one, I just needed the x, so it's going to be minus 2x. So we're going to go through and simplify this. 6x plus x, so that's going to give us 7x minus 5 over x times x minus 5. And now we're going to have 3x plus 2x, which is 5x minus 15 over x times 5x minus 15 over x times x minus 5. Now the reason that this method works so well is because now if we look at this, we're going to go 7x minus 5, and we're going to multiply by the reciprocal of the bottom fraction. So that's x times x minus 5 over 5x minus 15. And what's going to happen always is those are going to cancel out. Okay, so once we can get a common denominator, you can simply forget about it. It's gone. You don't need it anymore. And so our answer is going to end up being 7x minus 5 over the 5x minus 15. And there's nothing else that we can do with that problem. Oops, I wrote that wrong. Should be just x. Oh no, that's right. I actually need to jump back up here. I have 2 negative signs here. This should have been a positive sign there, which should have made this one, this should have just been an x. So our answer would be 7x minus 5 over x minus 15. So let's look at a couple guided practice questions. And I'm actually going to walk through these together. We'll do 11 and we'll do 13. And I'm going to use 11 using method 1, and I'm going to do 13 using method 2. Now, the reason that I'm going to use method 1 in example 11 is because if we look at these denominators, they don't have very many common factors. So I'm just going to get a common denominator in the top one, and then a common denominator in the bottom one, and then we'll simplify from there. So if we look at the numerator here, I'm going to get a common denominator of 6. Well, I don't have to change this one, so that's going to be an x. And then this is just going to be multiplied by 2. So I'm going to get that, and we have a common denominator. Same thing in the bottom. This is going to be a 10. And the first one I have to multiply by 2, so that's going to be 2x. And then we have the 7. So that's x minus 2x, which is negative x over 6. And 2x minus 7 over 10. So now I have 2 fractions. And method 1 will always give us this. We'll have 2 different denominators here and here. And remember, it's just like multiplying by the reciprocal now. And so now we see, is there anything that we can do to reduce this? And I can take a 2 out of both of those. And so our simplified answer is going to give us negative 5x over 3 times 2x minus 7. So that's how we would do the problem using method 1. So we're going to jump down to question 13, and in this one, we're going to use method 2. And remember, method 2 says I'm going to get a common denominator between all of these. And the reason that I would use method 2 in this case is because notice I have an x plus 5 in my top fraction, and I have an x plus 5 in one of the bottom fractions. So I might as well just get all of those denominators the same right away. And so those denominators are going to have to be, the common denominator is going to be x minus 3 times x plus 5. So I'm going to have that, and then I'm going to do the same in the bottom. X minus 3 times x plus 5 here, and also on the right side one. X minus 3 times x plus 5. So I'm going to get a common denominator between all of the fractions in here. So my numerator, or my common denominator is going to be the same in the numerator and in the denominator. So if we notice here, I need an x plus 3 here. Or sorry, x minus 3 here. So that's going to give us 3x minus 9. And in this first one here, I'm going to need an x plus 5. So that's going to give us 2x plus 10. And in the second one, I'm going to need the x minus 3. So that's going to give us x minus 3. And like we said before, if you get a common denominator in all of these, this is simply just going to cancel out. And if I factor that right away as I'm doing it, I'm going to get x minus 3. 3 times x minus 3. Add my like terms. I'm going to get 3x plus 7. We have 10 minus 3. And there is our answer. So in this section, we're dealing with a couple of different things. We're adding fractions. Again, remember, anytime we add or subtract fractions, we must get a common denominator. So we looked in this section at how to find that common denominator if we're talking about rational expressions. Also, in this section, we're talking about how to simplify complex fractions. We use two methods to do that. Method 1 is get a common denominator in the numerator and a common denominator in the denominator, and then simplify them. Method 2 was saying, okay, we're going to get a common denominator between all of the fractions in these problems, and then we're going to simplify it like that. So here is your homework assignment for section 8.5.